Hello everybody and welcome to the Kube Vanguard. This is part 2 of my V100 underground talk that I did at VMon, and this is going to be the demo portion. So just as a quick recap, my task here is to show application-aware backups with Kasten, and to do that though I decided to take a bit of a more interesting route than just conventional applications, and I'm leveraging AI. So I had, with the help of Claude, I built 2 little AI applications. One is an embedder or an indexer program that I built, and it embeds the small text file that I have into MongoDB, leveraging it as a vector database, as it can work as that, as I said in my previous video. And then I have an API program, it's called API, which is a chat box, and it queries the MongoDB vector database. And of course we leverage Kasten, but not just Kasten, we leverage application-aware blueprints in Kasten to make sure the database is in the proper state for it to be backed up, because we don't want it to be doing tons of transactions or anything happening which could make it to be corrupt or a crash consistent backups in conventional terms. Okay, so let's switch over to my console. This is a Ubuntu VM, as I said in the last video. So Ubuntu VM, it's running K3s Kubernetes, so a very small edge type distribution. Inside the K3 Kubernetes, we have a MongoDB, single pod MongoDB database, acting as a vector database. And we also have on this VM a Llama installed. Now, Llama is a local way of leveraging AI. So you can download models, chat with these models. You can do it from the command line, or you can, on top of that, put some chat bots. There are ones that you can just grab. You can create your own very easily with AI. So if you ask AI, the struggles I have here, or I'd say the limitations, are the fact I don't have a GPU. So without a GPU, everything's a lot slower. So to fight that, I've tweaked this as much as I could with the help of AI. And also, I'm using just one single text file. A single text file is just a text file full of information about syslog, and there's not a lot, so I'll just show you where that is. This is in a folder called Documents, and it's just syslog text. It's not very big. I just wanted to show the process, not the power. Obviously, to do something on a large amount of text or something like a PDF would require a lot more compute power. Okay, so what do? The whole process, as I described last time, is that I'm going to index or embed this syslog file into the Mongo database. So let's just check out the Mongo database. So here's my Kubernetes node. It's a single node cluster, K3s, there it is. Let's also take a look at what I'm running here as far as the models, which is important to point out. So for my application to run, they check this file called the M file, which I will show you in a second. Okay, and what we have here is the Llama configuration. And what's important to note here is the Llama embed model. So this is what Llama is going to leverage to embed the text. And then the Llama model for my application, which is Phi. I chose these models because they worked the best for what the jobs they need to do. In fact, Nomic embed text I knew was the best for this, very lightweight, small, fast. And Phi, I had to play around, and I'll show you those models now, because I left them all here. But as you can see, so here's Nomadic embed. It's only 274 megabytes, very small, lean and mean and fast. But as you can see, I tried a whole bunch of others. I tried Mistral, I tried Gemma 3, Llama 2, Tiny Llama, Orca 2, and I could only get things to work relatively quickly in the way I wanted with Phi in the end. The bigger ones were just too slow. I don't have GPU, so they were just taking forever. And Tiny Llama kept hallucinating. Even when it knew where to go, it just didn't work properly. At least that's, with my tweaking abilities, that was the best I could do. So let's do first the embedding. So we're going to embed that text into K3s, into the MongoDB. And just to prove to you that, let me just go over to my other, so I'm port forwarding. I'm using Tomux here, by the way, terminal multiplexer, so I can have multiple windows of command line through a secure shell. Okay, I never really got into using that before. It's a sidetrack here, because when I was doing the Kubernetes exams, people were warning me, be very careful, because you'll get stuck and you're in an exam and time's running out, so don't play with too much. So I kind of held off, but since I've decided not to do any more Kubernetes exams because they've gone too expensive and they're just offering these things like Kubestronaut and things like that, which just seem like a money grab, excuse me, but that's what it seems like. I've decided to go and use 2MUX and get used to it. So there it is. So here I am port forwarding. So the MongoDB database is inside a Kubernetes cluster, which is inside of its own clustered environment. So to show the applications or present the applications to the outer world, you need to do something. So generally in a production environment, you use something like load balancing or ingress, or the new gateway API, which I haven't looked at too much. But for testing environments, and I just want to do it fast and get it over with, you can port forward, okay? And that's going to present that port on the actual VM so that my Python applications can actually access it. Now, someone will say, why do you do this inside of Kubernetes? I actually tried it first inside of the same cluster to have a Llama running inside a container, inside the Kubernetes, but that's got the complexity to a state where it was just, difficult. So let's go back to the other window, which is Control B 0. So here I am. This, by the way, if you look at it, is running in a Python virtual environment, this VM, okay? You have to create that. There are instructions on how to do that on the internet. This basically creates an environment for your Python program and all its dependencies so that it's segregated. I guess the issue is that if you're doing this on a VM and you have other programs and dependencies that get mixed up, it becomes very, very ugly. I think I stated that in my first talk. Okay, so let's run the first program, which is the indexer. And to do that, I just have to type Python, and then let me just do a search so I can find it. I think I just recently tried it. There it is. So Python indexer.py. Which data directory, RAG documents. So anything inside there, it's going to embed. Press that, and off it goes. So this has connected to the Mongo database through that port forwarding into Kubernetes and has embedded that. You can see there the chunks. It's going to clear out. It should clear out the one that's in there before. Don't see it listed here, but it does that too, just in case, so I don't, make it all messy. Very simple and very fast because I'm using a very small model, which is specifically used to do this task. Works very, very well. Okay, so that is in the Mongo database. Let's just show you that. Well, I can't show you. I could go in there and show you, but like go into the container. But I'll just show you that it is in Kubernetes. So you got to get something. Get pods, and there you have it. There's my MongoDB running in there, and I could go in there and use enter the pod, or even from outside the pod, have commands sent into the pod that would show me like the databases and all that. I could actually do that to prove it, but I know you believe it. Okay, so what are we going to do next? Next, we're going to turn on our application, and to do that, we have to run our API program. So Python API, and we'll see it's running, and it's telling us that it is running locally on port 5000. So let's go to that. And this is a very simple chat box. There's Casson ready to go. But let's go to our MongoDB chat. And there it is. Okay, it says Orca, but I'm using Phi. All right, so let's ask it a question. So this text in this document is all about syslog, just things like severity levels, things like that, kind of general. I think I just got it from the manual. But I did put an Easter egg in there to prove my point. So what does Jeff love? This could take a while. It's thinking it could time out too. Again, processing power and GPU power makes a huge difference. Just using the CPU, I have heard on Macs it works better, but I don't have a Mac, so I can't tell. So this is thinking. While it's thinking, I'll quickly show. Oh, and while it's thinking, I can also show you that this will show me when it decides to answer. Created Jeff specific context. Okay, it's interesting. I don't know why it does that. Oh, because I guess it's saying that yes, it is. It confirmed that it is using the context. I had a problem for a while that it wasn't actually. It was connected to the Mongo database, but then it wasn't asking. It was still relying on its own context, and so that was a whole back and forth. I have no clue what in the end fixed it. It was Claude fixing it basically, but it was telling me, do you want to do this? And it had this long explanation. So you do learn a lot when you're leveraging AI. Okay, but what do I have here? I have the applications in Kasten, and if we go to applications, we will see here MongoDB. Okay, MongoDB, and I already created a policy for that, but I'm going to show you in a second what makes this application aware. As soon as it timed out. Isn't that unfortunate? So that will happen occasionally in this system. I'd be interested to see somebody leveraging this with GPU. See if it's faster. Let's just see. Okay. Interesting. This worked better at the V100. It was a lot faster, so it just goes to show. I don't know what's happening, but it's a very new technology. We'll just give it a few more seconds. Okay, so the minute I press pause, it decided to answer. It's typical. AI has a personality. So, Jeff loves being in the V100. No further explanation is needed based on the given context. So, I don't know where that came from, but this is correct. So, inside of that syslog text document, I put in the middle, Jeff loves being in the V100 community. So, this is proving to me that this application is not going into its own brain, which is huge, obviously for an LLM. Because it has no clue I hope it has no clue I'm in the V100. We're going to see that in a second. But it is actually getting this information out, and that's what I wrote in there. Jeff loves being in the V100 community. So there you go. That's the process. But, so what I want to show you also, though, and I'll show you in a second, is I created a second a Python program, which does not use the RAG. It's just using its own knowledge. So I want to show you that same question when I do that. But first, let's get business out of the way. So that Mongo database, where that embedded information is, which was just leveraged by my AI application, is living here. Okay. So creating a backup in Kasten is extremely simple, very intuitive. But what is different is the application aware. And I'll show you how you do that. And it's gotten much simpler. So Kasten is making a very strong effort to make this easier. I mean, it was already a very, in my opinion, compared to the rest of Kubernetes, easy application. But they're making it even better. And the way they do this is blueprints. We'll talk about bindings, a little bit more complicated. Blueprints, what are they? As I said in my last talk, you're basically getting something to happen inside your container or inside your deployments before you back up. So you're preparing your application for backup. And the way you do that, very similar to if you're running these things in a Linux VM. So, in this case, MongoDB, it's going to lock the database. So it's going to lock the database, snapshots can be taken, and then it's going to unlock the database after that's all completed. MySQL does the same thing, I think. Elasticsearch, there's one. But in this case, we're talking MongoDB. So it's called MongoDB hooks. We can actually create it here by creating a new blueprint. We can also, though, just look at one that's been created. And you'll see here a lot of YAML stuff, but you'll see here, there's the command. So it's a bash command, and it's going to basically, in here somewhere, it's going to leverage the password, obviously the secret, because it needs authentication, and then it's going to lock and then unlock the database. So here's the phases. This is the lock function where it's locking, and then I think further up, there was the unlock. It goes in the kind of backwards order, but that's what it's doing. Unlock. So it's very simple. It's just locking the database, so nothing is flying around when it's being backed up. But without that, you're doing crash consistent. So if you're leveraging a very powerful application with a lot of things going on, the chances of corruption increase. So you want to use this. Now, you've got your blueprint here. How do you add it to your application? Well, it couldn't be simpler. It used to be a bunch of command line commands, and you can still do them. But if you want to make this easy, or you've got a blueprint already created for maybe you have a bunch of MongoDBs, maybe you have a bunch of other applications. Now all you have to do is go here, you select the actual application here, you go to workloads, and you can see it's already there, and you press configure blueprints, okay? You press configure blueprints, and then you'll have a list of all your blueprints. Obviously, the blueprints are application specific. You can't use a MongoDB blueprint for Elasticsearch blueprint. Very convenient. So if I had a whole bunch of MongoDBs, I could potentially do that as long as the secrets and authentication are in similar structures. But this is just very simple. I mean, there's nothing to it, right? You add it, and then you just run your backup. And when you run the backup, it's going to, and mine just failed. Oh, that was on Saturday. I'm sorry. That's because I had the system turned off. Let's just run that backup. So go to our policies here, and we'll run it. We'll go back to the dashboard and see this thing in action. Again, it's all running on one single node, not too terribly powerful cluster. You'll say, okay, well, what is that? Where is that MongoDB? Well, I'm actually using Longhorn as a CSI. So my storage is Longhorn. In fact, we can actually see it from the command line or from the GUI, and it is leveraged. So that is on the node, on the actual like file system of the VM. Okay, so again, for demo purposes, if you're using a big application with powerful clustered storage, whatever, it'd be different. This is just for the VM purposes, but the concepts are all the same. So this is stateful data. This is not some kind of, you reboot the pod and everything's gone. And this is the data that you need to back up. So let's see how our backup's going. We'll go into here. It'll tell us the snapshot's taking place. And hopefully that'll finish successfully in a few seconds. And then I can show you the rest. Now, remember from what I said from my first talk, this is just a local snapshot. So we don't even consider this a backup, okay? You can restore from it. It's very fast. What the backup is once this completes, it's going to export it. And when it gets exported to object storage, for instance, in our case, UTB, that's when it is considered a backup. Okay, just looking at my time here. All right, so that portion completed. Now it says backup here, but even Caston's documentation says the backup is the export, but it is, I guess, the process they're talking about. But let's look in here. And if we go into here, we'll see a couple things that are interesting. The first thing I wanted to show you was the storage class. So there is my storage I was talking about. We're using Longhorn. Longhorn is also from the folks who created K3S. So it's now owned by Suzy, but it's Rancher. And it is you can actually use that in production. But in this case, I've just got it on the local machine. So this is stateful data, which is being backed up. And then right underneath that, the thing that most important, a blueprint. So there's my blueprint Mongo hooks. If anything hadn't worked with that, we would know this would be red and it would complain about not working. Okay. And then this will be exported. So the export part everyone knows about. It's going to be sent to my local UTB, or you can send to NDFS or S3 storage, which works with Caston. So that we've seen before. And so we would have the capability to restore from two locations. We've seen that before. So I want to go back to this and I want to show you my last little fun, interesting thing. So the other program I have here is this direct, okay? Direct API, you see it there? So let's do Python direct Pi. And this is, well, this is running on port 5001 because originally I thought maybe I had them up together, but then I decided against that. So let's just go back to here and let's go back to, oops, okay. Let's go back to this and now change it to port 501. There should be a warning there. Yes, there is. So this version does not use RAG, i.e. retrieval augmentation generation. This model has no access to your documents and will generate responses based on only its training. Okay, so let's go to Phi again and say, what does Jeff love? And hopefully this will come back, with something good, right? Because there are a lot of Jeffs out there. You don't know what this thing's trained on. It might find some Jeff that has some strange tastes. So let's cross our fingers on this one. With AI, you never know what you're going to see. I can just say it's hallucinating. Okay, so looking at my time here. Oh, what do we have? We have an answer. Jeff Love is an American writer known for his works on science fiction, fantasy, So, right. So completely not what the other one said. Jeff loves being in the V100. And remember, AI doesn't really care about spelling. It doesn't really care about grammar. It can figure things out, right? So I said, what does Jeff love? Actually, that was a question I asked before as well. And it came back and said, Jeff loves being in the V100 or the V100, right? Right. But without the vector database, it's giving me something about an American writer named Jeff Love, who I've never heard of, known for his works on science fiction, fantasy, and nonfiction topics. Okay, which is fascinating, but it's not what I asked. So that is the example. All right, thank you very much, and we'll see you next time on theCUBE Vanguard.